Okay, so guys, 14. We got a brick being thrown from the top of this building. We're told that the initial velocity is 15 meters per second. But look, is that 15 meters per second, is it perfectly in the x direction? No. Is it perfectly in the y direction? No. This velocity here is part x and part y. So what do we have to do to it? Break it into components. So with the red pen, I got the red going here. We're going to break this into x component and y component using trig, right? Just sine and cosine. Okay, so Vx, how are we going to get that x component? Using, we'll need the y too. We're going to need Vx and Vy. But let's start with Vx. Well, yeah. As it turns out, this problem does not depend on the x direction at all. But I was just going to do it to show you how to do it. But how would we get that x velocity? You're right, though. The x velocity is not going to be used. But how would we get it? Cosine 25 times 15, right? And then that comes out as 13.6. Okay, so the initial x velocity is 13.6 meters per second. All right, the initial y velocity, so this is going to be sine 25 times 15. So when you punch that into your calculator, you get 6.34. This is 6.34 meters per second. That's the starting y velocity. Okay, now look, as the brick flies through the air, so here are the ideas you have to know for projectile motion. No matter where we look at the brick, let's look at it right here. What do we know about the brick right here? The x velocity stays what? Constant. X velocity stays constant, so if it left the top of the building at 13.6, the x velocity is still 13.6. And just be aware, in real life, that's not going to happen, because what's in real life? Air resistance. But it's a physics problem. We ignore air resistance. Okay, so the x velocity stays constant. Now what's happening to this y velocity? Is the y velocity staying constant?
No.
No, because what's acting in the y direction?
Gravity.
So basically, acceleration x is 0, right? Because acceleration is any change of velocity. Acceleration y is gravity, which is negative 9.8. Now look, here's what the question wants us to figure out. Oh, they tell us that the time in the air, the total time in the air for the brick is 3 seconds. Okay? Now look, this problem can be very difficult or very easy. Now, what a lot of kids do, I've done this problem for many years. What a lot of kids do is they break this into multiple parts. They're like, okay, solve for, the time to here, right? How much time does it take to go up? And then the time from there to there is the same as the time to there. So they break it there again. Then subtract that from 3 seconds. Then the time all the way down to there. You guys know what I'm saying? Like breaking it into multiple parts. You could do it that way, but there's a very easy way to do this problem. It's super easy. And the easy solution requires, let me make some room here. The easy solution just requires knowing that when you write out the kinematic, when you say y equals 1/2 gt squared plus vy initial t. So look, this is the first kinematic. I wrote it for the y direction. This y is a displacement. What does displacement care about? Nathan?
Vector.
It is vector. But back when I first taught you displacement, Displacement cares about two things. What are the two things that it cares about?
Magnitude and direction.
Well, yeah, it's a vector. It'll have magnitude and direction. But look, where does the brick start? Here. The brick starts here. Where does the brick end? Over here, right? The y is the vertical displacement. What is the vertical displacement going to be? It's going to be this right here, which happens to be what? The height of the building, right? In these kinematics, y and x, they are displacements. They care about starting point and ending point and the vertical distance in between. Or if you're in the x direction, or the horizontal distance in between. Does that make sense? Y is a displacement. So check it out. We go, okay, y equals 1/2. Now what's g? Negative 9.8. Time in the air is what? 3 seconds squared. Plus, I'm going to come down here. All right, what's Vy initial? 6.34 meter per second times 3. This, and the answer is going to come out negative. Why does it make sense that it comes out negative? Well, look, did the brick go up or down? Down. So it makes sense that the answer comes out negative. In fact, what's this going to be? Who punched this in? Who did this already? What did you get? 25.1. So it comes out as negative 25.1. So what's the height of the building? The height of the building is just going to be what? 25.1. Right? We found it by figuring out how far the brick went down. So the key to this problem is that y is a displacement. Displacement cares about starting point, ending point, and the distance in between. You guys get it? Now, hey, just to be awesome at physics, hey, how many of you who did this, how many of you tried the approach of breaking this up into multiple parts? That's the most common thing I see kids doing, which works. You can do it that way, but it just gets a lot more messy. All right, should we do one more?
15.
Should we do 15?